I've gone ahead and drawn a free body diagram for this problem. The only forces acting on this at the curve is gravity and the normal force, which instead of coming from, it comes from the surface that it's on, which is on the curve, so it goes at this angle. First thing we need to do is get the sum of our forces in both the x and y directions. So to get the sum of x, from the second law, we get mass times acceleration. And we also know that the only x force that we have is the x component of our natural force. That gives us this combined equation because these two must be equal if they're both the sum. Same thing happens with our y. We use Newton's second law. We don't have any acceleration in our y direction, so this is equal to 0. The other y components we have are gravity in the downward direction and the y component of our natural force in the positive direction. So we have this subtracted from this, and that gives us this equation. From this second equation, we can solve for the natural force, which gives us this equation. And then by plugging this equation into the first one, replacing f of n with this, we can get this final equation. And from this equation, we can reduce, mass cancels out. We are left with a radial acceleration equals this. The equation for this is velocity squared divided by radius. So with further simplification, we get finally our velocity is equal to the square root of gravity times tangent of 30 times the radius. We know gravity and we know radius, so we can fill these numbers in, and that gives us our velocity of 9.21 meters per second. If we're not fast enough to, even without braking, to get to this speed, then we need to reduce this angle of 30 to something lower, because the lower the angle, then the less velocity you need to bank it perfectly. If our angle was higher, then we would need a faster velocity to bank it perfectly. To find out what the speed we need on the moon, we can simply use this equation here that we already simplified, and instead of using 9.8 for gravity, we use the force of gravity on the moon, which is 1.6, and we get 3.72 meters per second.